everyone. Welcome to Close Up on America's Business, the program that takes you inside some of the most unique and successful companies in America. I'm Janice Marie. On each edition of our show, you have the opportunity to meet some of the most innovative business leaders in the country today. You'll find out what their products, services, technologies, and business models can do for you, and what they're doing to change our world and to change the way we do business.
From cell phones to jet fighters, rechargeable batteries are playing a critical role in powering our world today. And as these batteries get smaller and more efficient, practically everyone stands to benefit. And that's exactly what is happening here today in the facilities of this company named Electro, headquartered in Danbury, Connecticut. This is best described as an advanced battery development company, which for the last 15 years has stood at the forefront of research and development in battery technology. Their goal, create batteries that are more efficient and last longer, and they've been doing exactly that. With the added benefit that theirs is US-based manufacturing, important for clients concerned with issues like security, quality control, and others. The president of this company is Michael Reed.
Electro is a small startup company. It is a public company, but it's a company that's based on developing advanced battery technology for a variety of applications. Earliest work has been done with the Department of Defense, and what our whole mission is about is to try to provide a smaller, lighter, more powerful energy storage device so that the soldier or individual can be more mobile in their activities and operate longer periods of time without having to lose the battery power.
This is a conventional Toyota Prius hybrid electric vehicle. What we did to demonstrate the EEI's Electro Energy's bipolar wafer cell technology, which is this flat cell, is to convert this hybrid electric vehicle to a plug-in hybrid vehicle by adding additional batteries. Each one of these batteries, there's 4 battery modules here. Each one is rated at 108 volts and 15 amp hours. Each battery module contains 90 of these cells stacked up in this configuration, and then these modules are put in a series parallel configuration to add 6 kilowatt hours of extra energy to the Toyota Prius. And what it does, it enables us to drive this Prius in an all-electric mode for 20 to 25 miles, up to 34 miles per hour, and that's a function of the Toyota Prius. Toyota has built-in electronics that enables it to drive an all-electric, but 34 miles per hour is the limit, and that's a limitation due to the electric drive. We have automatic conversion, so when you're in the conditions that allow all-electric driving, it'll automatically go into electric driving. When you exceed that speed or exceed an acceleration point, the engine will turn on automatically until you reach conditions where you're favorable for all-electric mode.
So how does it work when you do a product for the military? Explain that to me.
The company originally began working on advanced battery chemistries, not the older lead acid or NiCad chemistries, but a new chemistry called nickel metal hydride. And this is a chemistry that has much more energy in a smaller package and lighter package. We've developed applications for the Department of Defense in demonstrating this technology for applications such as the aircraft. We built batteries for the F-16 fighter. We've built batteries for high-energy weapons, development projects for the Department of Defense, and we're basically developing an advanced battery system to provide a longer-lasting, more powerful, smaller and lighter battery. Further chemistry has come along. We now are involved in lithium-ion chemistries in our battery designs also, which even further increases the energy density to about double that of nickel metal hydride. We are doing advanced development work with the Army and the Air Force, applying this into new battery systems.
The Toyota Prius gets about 50 miles per gallon. If you drove this car 40 miles, 20 miles of all electric and 20 miles of hybrid mode, it essentially averages out to about 100 miles per gallon. If you drive less than 40 miles, you can get a lot better miles per gallon. If you drive more, obviously it's going to be a little lower. But typically, most drivers in the US drive less than 40 miles a day. It's an ideal car for somebody commuting. There's an energy savings, which translates to dollars, about 4 to 5 times the cost savings with electricity versus gasoline. The Prius was really just a platform for us to demonstrate this wafer cell technology. From this, we're venturing out to other applications, larger trucks, larger systems, going from 6 kilowatt hours, which is here, up to 30, 40 kilowatt hours for larger bus applications and truck applications.
The real question is that what do you think it is that separates this company from others that are doing the same kind of research and development?
The unique characteristic of our company is our technology. We have developed a bipolar wafer cell. Instead of the standard cylindrical cells or prismatic cells that you'd normally see, we have a cell that is a very simple construction. It is a cell that has a current collector on each side, and within these two current collectors we have a layer of positive active material, a separator, and a layer of negative active material, somewhat like a sandwich. And this whole wafer cell then is encapsulated in a plastic membrane, leaving contact surfaces open, both the positive current collector and the negative current collector. So this makes the battery cell. This is a 1.2 volt nickel metal hydride cell. When we stack these together, the contacts are made between these adjacent current collectors, so that if you wanted a 12 volt battery, we would stack 10 of these together to get a 12 volt battery with 10 of these 1.2 volt cells. We've acquired a major manufacturing facility in Gainesville, Florida to produce these batteries in larger volume. It has a high volume manufacturing location. Most of what we've done so far has been R&D at the battery and cell level. Now we're developing applications, and we're about to go into a full commercial phase of selling these batteries to both the military and to commercial customers.
In addition to the automotive industry, we're interested in other aspects of transportation, heavy-duty trucks, buses, and then also smaller transportation modes, such as scooters, bikes, and other electric means of transportation. In addition, we have programs with the Department of Energy, where we've worked on stationary applications, which working with utility companies to help do load leveling, peak shaving, and other distributed types of energy.
The bipolar technology is what has been patented. We patented the fundamental design itself, as well as the materials involved, the methods of manufacturing, and in some cases the specific applications we're working toward. This is unique technology that nobody else in the world has today. The bipolar technology itself is something that has been theoretically possible for many years, but at the heart of our technology in our patents is how to make this bipolar cell and make it work. Toyota Prius already is a very nice car with a 40+ fuel economy in the hybrid mode, but when you plug in and use it in the electric mode, you can actually get well above 100 miles per gallon on the equivalent cost basis using the energy from your 110 volt outlet in your garage.
And there you are, an inside look at some of the latest advancements in the world of battery technology as being conducted here in the labs of Electro Energy. I'm Doug Llewellyn reporting from Danbury, Connecticut.
Well, that does it for this edition of Close Up on America's Business. I'm Janice Marie. Thanks for joining us. We'll see you next time.